When you turn on the radio in your car, where does that actually come from? Let's take a tour of the transmitter site.
Hey, this should be familiar. This Intraplex unit pairs with the one at the studio, except there are things connected to its output rather than its input.
After the audio leaves the Gates Air IP link unit, its first stop is this device. This is an Omnia 9 FM audio processor. It serves as a compressor and limiter to the audio so the transmitter doesn't get overmodulated. I'll go over audio processing in a later video. In our setup, this device is responsible for generating the actual FM multiplex signal that we feed the transmitter with. We also have an Omnia 6 as a backup.
Have you ever wondered how your radio shows you the name of the song and the artist you're listening to? It comes from this thing. This FMB80 device receives what we call program-associated data from our automation playout and generates an RDS subcarrier that's sent to the Omnia 9 and overlaid on the FM multiplex signal. We'll talk about the different components of the FM baseband in an upcoming video. The Omnia processor also has an audio output that we send to these devices. This is how a radio station's HD1 feed is captured. The Inovonics Justin 808 aligns the HD radio audio path with the analog FM signal, so if you lose the digital signal, it's a relatively seamless transition. The audio is then sent to this HD radio importer-exporter where it's added to the digital radio signal and shipped off to the transmitter. HD radio in North America has a lot of moving parts. Maybe some of our overseas engineers can tell me if DAB is simpler.
This is where the magic happens. This is a Noctel GV30N FM transmitter. These are a bit smaller than transmitters of the past because they're solid state and they're modular. With this one, you can even open the front panel while the transmitter's running. It's not interlocked, and now you can see some of the modules inside. Down at the bottom, we have power supply modules that are hot swappable. Then you have the controller and the exciter. The exciter is what actually generates the RF output signal. Then it goes through this bank of power amplifiers. Each one is responsible for about 3 kilowatts of forward power from the transmitter. Then everything is combined and sent up this rigid coaxial transmission line. This is not like what you plug into your TV or cable modem. It looks like copper pipe, because it essentially is. And just in case, we still have a vacuum tube-based backup transmitter.
This antenna switcher is how we send either the main transmitter or the backup to the antenna. It's motorized and controlled by a panel we have mounted in the racks. Of course, then the signal gets sent up the tower to the antenna. Usually on towers like this, there's a TV station at the very top. FM radio station antennas are usually mounted to the side, a little further down the tower.
Just like the air chain here in the rack room, the transmitter plant has a lot of things I could, and will go over more later on. I'll be activating the Q&A feature on my TikTok channel so you can send in questions you'd like answered in a later video. Until next time, make sure you follow for more.